Hello and welcome to Unit 2. All right, there are 5 units that we're going to cover. This is Unit 2, and you should have a packet in your notes that begins with this page, with graphing quadratics. This whole unit is over quadratics. And quadratics have the highest power. They're going to have a power of 2, or an exponent of 2. All right? So when I see quadratics, I know that. So all quadratic expressions or quadratic equations are going to be written in this form. ax squared plus bx plus c. And we've even looked at that a little bit while we were doing factoring. And when we talked about multiplying a times c, that's where a and c come from. We just had an expression then, though. There was not an equal sign. When we graph this, it creates a U-shaped curve, not a straight line. And this graph is called a parabola. All right. And then I am absolutely terrible at trying to sketch these without actually making some points. And so I will show you. At this point, we're not looking for super precision, but for this one, x squared plus 2x plus 5. So, or 2x minus 5, my bad. So the last number is always going to tell me where it crosses the y, and we'll talk about this more, but that always tells me where it crosses the y. So I know that it's going to cross the y right there. I know that's where it's going to cross the y at negative 5. And if I do a little more with this problem, or if, as it says here, I use a graphing calculator, I found out that its vertex, that's the turning point, is down here at like negative 1, negative 6, which is probably a little, and then it goes this way and this way. So a few things that we know easily is that because the a value, which in this case is a 1, the a value is positive, then the parabola is going to open up. It opens up like a smile. My other case over here, it's going to open down if it's negative. If the a is negative, remember the a is the number in front of the x squared. If it's negative, it's going to open down like a frown. And so this one I know is going to cross at 7. And let's see here. It's not a very neat, hold on a second. And I know it's going to go down. And let's see if I can, this will not let me switch over without erasing everything. Hold on a moment. Right. So you see we are now blank again here. This one is, I know it's crossing here at 7, and just did a little extra math so I could find out for sure. Its vertex is up here, and then it's going this way and this way. And you see that this is negative, so it is opening down like a frown. So Those were not meant to be super accurate graphs, just to show us some basic things like the up and down, the way it opens. So each parabola is going to be symmetrical. And so let me show you quickly here. That last one we just did, this is an exact graph of that. And if you look at it, and if I would draw a line down through the vertex meaning the turning point, if I drew a line through the vertex, if I could trace a line, all right? If I drew a line through the vertex, then I should be able to fold the parabola in half, and each side is the same. That line is called the axis of symmetry. It's the line that splits the parabola into two mirror images, I should say. Splits the parabola into two mirror images. The axis of symmetry is always going to be x is equal to something. So in this case, it looks like x is equal to 1.5, which is really messy. But that next solid line is 2. So 3 lines in between 0 and 2 would be 1.5. It's always x equals because it is a vertical line, straight up and down. And it's an equation. So if you're asked for the equation of the axis of symmetry, you can't just put 1.5. It's not just a point or a number, it's an equation. So back to our notes. You can, back here on one of your, back here, like on this, turn my pencil back on. Back here, you could sketch yourself and mark that as axis of symmetry. We'll have a chance to do some more things with that, so never fear. So let me give you a nice, hopefully nice, definition of axis of symmetry. Let's get things a little bigger here. So for those of you on smaller screens, you have a chance of seeing what I'm writing. All right, the axis of symmetry is going to be a vertical line that divides the parabola into two mirror images. Now, when we are in standard form, there is a formula that allows us to find the axis of symmetry. And that formula is x is equal to negative b over 2a. Negative b over 2a. So we take the opposite of b, and then we divide it by 2 times a. So think of the one I just showed you, and I said the axis of symmetry was 1.5. The middle was a 3, so that would be negative 3. And the a was a negative 1. So negative 3 divided by negative 2, because 2 times negative 1, that's why it equaled 1.5. Or I could have said, left it as 3 over 2. So that's an example from above when I found the axis of symmetry was equal to 1.5. So I'm going to have to erase some of that so I have a place to put my definition for vertex, because that needs to go right here. Let's tidy this up a bit. Negative b over 2a. All right. So our vertex is the turning point of the parabola. And the vertex will always either be the lowest point of the parabola or the highest point of the parabola. If it's the lowest point, it's called a minimum. And we oftentimes we'll just call that a min. So it's the minimum, aka nickname of min. And if it's the highest point, it's called a maximum. It's the highest number that it reaches. And we also call that a max. I know. So the one that opens up has a min down here. The one that opens down has a max. It has a highest point. And in the other direction, they just keep going forever and ever. That's why they don't have a highest. The top one doesn't have a highest point. The bottom one doesn't have a lowest point. All right, so let's look at a quick example. It's going to be very sketchy. All right, so for this example, we have the equation x squared plus 8x plus 15. So to find our axis of symmetry, remember that formula is x is equal to negative b over 2 times a. So the opposite of b, in this case, a is 1, b is 8. C is 15, although we don't need that at this point. So this would be negative 8 over 2, which would be negative 4. So my axis of symmetry is x equals negative 4. My vertex, so the vertex, because the axis of symmetry always goes through the vertex, the first part of the vertex is a point, so it's an ordered pair. The first part of the vertex will be the same as that axis of symmetry. And then to find the rest, we plug that number in. So we're doing negative 4 squared plus 8 times negative 4 plus 15. I'm going to run myself right out of space. So that's 16 minus 32 plus 15, which ends up being negative 1. That's my vertex. So to make my sketch, I'm going to just use, you can put yours over to the side. I'm going to use this as my x-axis and this as my y-axis. So negative 4, negative 1, 1, 2, 3, 4, negative 1 is here. This is my axis of symmetry. Let's make that a dotted line. And then I know that this is going up because it's positive. Now that's a very rough sketch. And I also know that this has a min. And so, and the min here, if they ask you for the min or for the minimum, the min is negative 1. So the min comes from the y portion of the vertex. It's like, how low does it go? And if it was a max, it's answering the question, how high does it go? On the next couple pages, what we have are some notes. I've kind of Frankenstein together what Miss Miriam used to use and what Miss Melissa in Richmond used, so that you kind of have the best of both worlds. You may or may not think that. but some of the things that I've tried very roughly to sketch, you'll see you have on your next page of notes. So there's our function, and remember that we said f of x and y, that equals the same thing. So that really is the same thing we just wrote. You see the parabola, and then the vertex is marked, and then the places where it touches the x-axis, those are called the zeros. And we'll learn more about the zeros or the solutions or the roots, have lots of names, later today. So when we talk about the domain, we're talking about what numbers can we use for x. Well, we can put anything we want in for x. So we just say that the domain is all real numbers. And this fancy looking R with a double bar at the front, that's all real numbers. That's like a special symbol that means all real numbers. The range is what can we use for y? What does the graph use for y? Well, if it has, in this case, this graph has a minimum, that means the y's are all greater than or equal to, what's the lowest point it gets to? 1, 2, 3, 4, 5, -5 maybe? I'm going to have to touch it to see. 1, 2, 3, 4, 5. Yes, -5. Whew. My eyes just can't handle that without touching it. All right, so that's basically just some notes. There's not much for us to actually do there. Just a place that already gives some definitions without us having to fill things in. And then you see, here we go. There are some of the things I'd already given you. I defined the vertex differently, that the vertex is the turning point. It's both of the things. And then you see an example with a max and an example with a min. So here's our standard form. And then again, this is a nice reminder that this axis of symmetry formula is on your reference sheet. That first sheet, it's on the back of the factors. And if I want to find, when I'm finding the vertex, I need the axis of symmetry, which I can find with the formula, and then I find the y coordinate by substituting in. And then the A tells me if it's going up or down. So let's look at an example, and we're going to make a little table here. So first we want to find the vertex. So to find the vertex, really have a to find the vertex, the first thing we're going to do, if it's in standard form, the first thing we're going to do is the axis of symmetry, which remember is always going to be x equals -b over 2a. So -b, so the opposite of -8 is +8. And then this is just a 1 if I don't see anything. So 2 times 1 is 2. So x is equal to 4. So I know my axis of symmetry is x is equal to 4. So I'm going to come over here on my graph, and I'm going to find where x is 4. There's 1, 2, 3, 4. And I'm going to attempt to draw a dotted line straight up and down along x is equal to 4. I know that that line, that green dotted line, is where the line that's going to divide my parabola into 2 mirror parts. So then I'm going to start plugging in numbers to find, first off, the vertex. So if x is 4, now I plug 4 in, and this is just giving us a little spot to do that. So this is 4 squared minus 8 times 4 plus 14. So that's, you can just type that all in your calculator. And then that turns out to be -2. And that's the answer that comes out when I plug 4 in. So 4, -2 is my first point that's on this parabola. So 4, -2, I'm going to put our actual parabola in dark blue. So 4, -2. So there is my vertex. And we know that this is going to be heading up, right? We know it goes up. That's the direction of the graph. And then choose one side to make a table. We don't need to do both sides because it's going to mirror. So since this was 4, I'm going to go one bigger and use 5. So I'm going to do 5 squared minus 8 times 5 plus 14. So that's 25 minus 40 plus 14, which just turns out to be -1, right? So then this is 5, -1. So 5, -1, which would be right here. And because of the axis of symmetry, I know if there's a point there, there's also, he has a partner point over here. His mirror image point is over here. And then I would try 6. So I just go one more to the right. I do 6, so I'm plugging 6 in. 6 squared minus 8 times 6 plus 14. And so I have 36 minus 48 plus 14 is going to give me 2, I believe. So 6, 2. So 6, 2 is here. If my iPad will let me draw a dot. And then that's 2 away from the axis of symmetry. So 2 away the other side also has a point. And then I try to connect these. I don't need to make it really quite go up that high, but I also know, because of that plus 14, that this does not cross the y-axis until 14. So on my graph, it doesn't really touch the y-axis yet. Now, IXL is going to make this much easier for us than it is on paper. So there are some benefits to being online. But that is the process by hand on paper if we start out in standard form. And I see that I've given you 2 pages of exactly the same notes. So I guess if you messed up one, you have a spare. So let's switch gears a little bit here and look at what some of your assignment's going to be on IXL. So we're just looking for characteristics of the graph. So looking at this graph, what's the y-intercept? So the y-intercept is where it crosses the y-axis. So where does this cross the y-axis? Up here at 9. And it doesn't matter. Notice it's not giving you an ordered pair. It's just giving you a place to put one number. Doesn't matter that that's actually also the vertex. It's just where is it crossing the y-axis. So we just type in 9 and move along. So this one is asking for the coordinates of the vertex, and it helps you out. It gives you an ordered pair. So this is my vertex down here at the bottom. So I need to remember that x goes first. So it's 2 from the left, 2 to the left. So -2, and it's down 4. So I'm looking at the coordinates for this point. So it's going left 2 and down 4. So what's the y-intercept? Well, it's just crossing the y at 0. What are the coordinates of the vertex? So it doesn't go left and right, so the x-coordinate of the vertex is 0, but it goes down 5. Now, this asks, what's the equation for the axis of symmetry? So, equation, so you always have to type x equals, and then remember it's the line going up and down. So in this case, x is equal to 0. It's also the same as the x of the vertex. So you don't have to use a formula here. You're just getting it from the graph. What is the minimum value? So what's the lowest this goes? 0. So this, we're just taking all these things from the graph, just getting information from the graph. X equal 0 again. So here the y-intercept is 0. So it's crossing right here in the middle. And in this case, if the vertex is at the origin, 0, 0. So that's going to be your first lesson on parabolas. You're just looking at the parabolas. That may have been less confusing if I had started there. And then if we look at the equations, oh, no, that's not one that I actually assigned you. I did assign you K3 though, so K3. So here we are practicing plugging in the numbers. And I cannot stress enough how important it is when you're using a calculator that if you're squaring something, you put it inside some parentheses. Or you could just think to yourself, x squared, negative 2 times negative 2 is 4, 2 times 4 is 8, and 8 plus 8 is 16. But if you're going to use the calculator, be sure that you're putting that negative 2 inside parentheses, and then the calculator will know that I'm squaring that part before I multiply by 2, and then I'm adding 8. So these are going to have multiple parts, so this can take a little while. If you're missing them, pay attention, and if you're not sure, ask. So then negative 1 squared is 1, 2 times 1 is 2, 2 plus 8 is 10. Go back. 0 squared is 0, plus 8 is 8. 1 squared is 1, 2 times 1, so I'm plugging it in, and that would be 10. And it's going to be common that you're going to see these two things have the same number because of the symmetry if we would graph this. So this time, it's really more of the same. So just plugging in and evaluating. So 2 squared is 4, 5 times 4 is 20, 20 plus 6 is 26. 3 squared is 9, 9 times 5 is 45, plus 6, 51. So you want to be really careful that you're actually typing everything in if you're going to use the calculator. So negative 8 times negative 2 squared plus 8 times negative 2. So negative 2 replaces both the k's. So this becomes positive 4. And positive 4 times negative 8 is negative 32. And negative 16, negative 48. So try typing that into your calculator. You should be able to type it in all at once, like the first thing I wrote down, and just hit equal once at the end to get negative 48. All right, so that's what's going on in K3. And the reason I assigned that is normally if we were doing this on paper, you would have to find points and you would have to complete the table.